Welcome back, everybody. We are talking about chain drives today and sedimentation basin flights. What is a flight? Well, it's a sludge scraper arm that's in the basin, and I'll show you that later in the video after they're back in service. But what they do is they move the sludge to a hopper that is settled in a rectangular basin. See, this is kind of a long rectangular basin, and it pushes it to a hopper where it can be pumped to the next level of treatment for solids handling. Well, I came into work one day and I found that this disc on this sprocket assembly was moving with the gear drive driving it, and this chain is supposed to move, and it rotates an axle and it pulls the flights very slowly so they can do their job. But what I noticed is this wasn't moving, but that motor was running. And so I'll show you what I saw when I pulled the cover off, and that was this. See, the disc is moving, and it should be moving and turning this. But in these holes go what are called shear pins, and those shear pins snapped. Now, what caused them to snap? We are going to find that out. We're going to have the contractors are going to do an entry tomorrow and look at all the scraper arms and flights and the axles in there and anything that's moving, and make sure nothing's getting hung up. But there's something I found that may be the culprit. We're not sure. But I want to show you something, and this is the kind of the genesis of this video and why I've decided to shoot it. Look at that disc. What, you see something odd about it? If you don't, it's fine, because I didn't at first either until I grabbed it and moved it. It's about ready to pull out completely. The bearing is completely gone. This should not have any play in it whatsoever. So yeah, this is toast. Thankfully, though, we have a critical spare parts inventory. If you don't have one at your plant, I suggest you get one. I'm not here to make recommendations on how you operate your plant, but what I can say from my point of view is having this on the shelf brings my blood pressure down several points, because having stuff like this here versus 8 to 16 weeks lead time when you order them, this isn't something they stock at Home Depot. This is stuff that you need to they need to make when you order it. They don't keep a lot of this stuff in inventory. What we're going to do tomorrow is pull this out of here, remove this assembly. I've got a shear pin. Unfortunately, the shear pin that came from the manufacturer is a little small. I'm not entirely sure what's going on here. I looked at my other one, and there is a bushing that goes in here, so I don't know where that bushing went. There was another party involved at this plant, and they were great. It looks like they fabricated their own shear pin, but it's not going to be a big deal for me to get a bushing of some kind. I've already kind of figured out a bushing solution. We'll see if it works, but I don't see why it wouldn't, and I'll share that with you when we get there. So this is the tensioner here. What we're going to do is we're going to pull all this apart. They're going to set it here, make sure that the chain and sprocket is all put back together properly. They want me to wire it up. That's fine. I'm going to wire it up. They're going to do an entry. They're going to clean the basin out. They're going to check all moving parts and make sure everything is working fine. And then we're going to put this thing back in service. 2 notes. This video is mostly about the gear reduction and the chains and the flights. This is not a confined space entry video, so I'm not going to be filming them entering and all that stuff. We'll do that at a later time. What we're going to be focusing on is the gear, the chain, and the flights. And at the end of the video, what I'm going to do is show you on the whiteboard how all this works and how this all ties together. But let's go on to the next segment. We've already got this down here. Let's cut over to actually doing the work, and join me while we fix the gear reduction. Let's go. Okay, so here we are, locked out and tagged out on the secondary tank drive, and we are locked out and tagged out on the tank 2 scum skimmer, because some of the confined space equipment actually goes past the skimmer. We don't need it anyway, but we're locked out and tagged out there. Just want to demonstrate that to folks. This is in the control room B. We have 3 control rooms here. But I'm going to take you up. The project's not going quite as smoothly as we'd hoped. There's a keyway on the shaft for the drive that has the sprocket stuck on it. Kind of show you what's going on here. One of the guys still working on trying to get it busted loose. Show you the drive is off. It's clearly a work site over here. So that's where the drive is supposed to be. The new one's going right there. And we've got our electrical terminated safely. And like I said, we're locked out and tagged out. We've got our chain kind of rigged up right there with a hammer. But yeah, so what we've got here is we've been working for the last couple hours. This has been where we've been at for a lot of the time, trying to get this keyway off of this sprocket. And I'll look in there where he's digging. It's just really rusted and stuck on there. We found some set screws. We've tried to pry it off. We used the more hammer and block method. We're concerned about using a bearing puller because it might snap the plastic disc. So just an update on where we're at, and I will check back in after we've made some progress. Okay, so what you're looking at may look like a crime scene, but I'm not going to pretty up a work site for the sake of YouTube. This is a day in the life stuff. This is what some of this stuff looks like. So what ended up being the solution was more hammer. What this is right here is a keyway, and that's designed to keep us from having to press something on, and it should slide right off. But this thing's been in service for a long time. We're in coastal salty air, and it's seized up. What's really funny is this is plastic, so we were really surprised at how much effort it really took to get this thing off. So anyway, next step is to get the new one, which I've already wired up for 230 volt, and what we're going to do is set it, get the sprocket put on that one with the keyway, and we're going to put the chain on, check tension, check rotation. I'm going to wire it up, and we're going to go get the flight system back in service. All right, we are hooked back up. The tensioner has been tensioned nice and tight. I don't know if I actually tested that for you guys before, but it was slopping around, so it's reset. It appears that the deflection was probably the problem. They pressure washed everything. There was nothing the flights were hanging up on. Everything looks great. I fabricated these little rubber bushings. They're okay. I'm probably going to come back and make it a little cleaner. The other thing is I've got my wiring still open because I checked rotation right before I had to jump on a meeting, actually. So I'm coming back after that meeting and just showing you guys. There you go. It's moving nice and slow. And that's kind of how you want it to look. So I'm going to clean up my electrical work now that I know that I've got the leads landed in the right place. And I tried to shoot a video already, and this is my second take here. It's way dark down there, so it's kind of hard for me to show you how these flights work. But as you saw how slow that chain was moving, they just moved real slow on the bottom, and they pushed the sludge really slowly, all the settled solids, to a hopper, and then they're transferred over to this pit over here that pumps back to the primary clarifier for settling, and then to our anaerobic digester for solids reduction. And as you can see, the crime scene from where what it looked like a crime scene anyway, from where the poor old gear drive was beat all to hell because we needed to get it off that shaft. That's all been cleaned up. It's been reassembled, and I'm going to take it to the shop, one of my favorite vendors locally, to get it repaired and put back on the shelf for critical spare parts. And just so you can see, remember at the very beginning of this video, there was a lot of play in that sprocket. Nice and tight. So there should be no play whatsoever. I've got full confidence in this, and you know what's super awesome about this project is because this project's now done, I can use this basin, and this basin that I'm actually on right now can be used as a primary clarifier. There's an alternate way to run this plant, and that means we can now greenlight the project to line the primary effluent launder in the primary clarifier that's failed, And we've got that project scheduled for late April. So I'm super excited to take you guys along with me on that, just making sure that we're not touching that concrete and we're looking good, good clearances. Sorry, saw something shiny. But I'm super excited to bring you guys on that project with me. And we're gonna have the clarifier completely drained. The same guys from GSE are gonna come and they're gonna inspect all of the rakes and the hopper and the baffles and all that stuff. I'm super excited about it. But for now, let's go to the whiteboard and let me draw out for you how all of this works so you have a better understanding. Okay, welcome to the whiteboard segment of the episode. I want to take care of a couple housekeeping items before we get into all this. The first is, if you have gotten anything out of this video so far, please like and subscribe. Pass this to anybody who's studying. Let's grow the channel and let's help people get certified. Second, I shot a supplemental video while I was up there beating on that Sprocket with them, and then there ended up being 4 or 5 people there, and I was probably the weakest of the group, to be quite blunt. So I let them wail on it, and I came to my truck tailgate, and I changed the wiring configuration in the motor to fit the proper voltage. So we have 230 volt 3-phase on that part of the plant, and the pump came wired for 460 volt. So I changed it, and there's a wiring diagram inside. It was very easy, but I will link to that video. I'll upload both videos today and link to both of them so that you can see. If you're watching this video, you can go to that one easily, and if you're watching that video, you can pop over here and see this one as well. And then the last thing is apologies for the kindergarten art. I'm just not very good at art. So let's get to it. I haven't said it yet in the video, but I want to make a point that there's a reason that these flights move so slowly. It's so that it doesn't kick up the settled sludge. It's not very dense down there. It's still mostly water. And if those flights and scraper blades move too fast, it'll kick it up like dust in the wind, So that's one thing you should know. If you're asked about it on your exam, these do move quite slowly, and that's why. Something else I want to mention, flights versus scraper blades. You hear me saying collection, flight, system, and flights. There's a reason I prefer the word flight over scraper blade, and you need to know both terms, by the way, for your exam. They've shown up, both of them have shown up on my tests before. Scraper blade has kind of a descriptor in its name that makes it sound like it's scraping across the floor, and it's not. It's actually floating off the floor just a little bit. They're not rubbing up on the floor. Because if they were, they would snap a shear pin or they'd overload the drive. There'd be very high risk for that. So instead, they're just a smidge off the floor, and say they float off the floor, and that's where the word flight's it's a little bit of a memory tool for me. But yeah, they do scrape the sludge down towards the hopper, but don't just know that there's a little bit of clearance off the floor, and know both the terms. Okay, so what are you seeing here is you've got the drive that we just replaced up here, and it turns that chain. There's another big sprocket down here, and it turns these shafts, or I've been calling them axles, but they turn these shafts, which drive another big chain that has the blades attached to it. Okay, and as it turns very, very slowly, these blades so there's sludge settling. There's secondary sludge settling to the bottom, and it's just pushing slowly towards the hopper. Okay, and this is the aerial view. If you were to look, you'd see 2 chains going there attached to these shafts, and it's quite tight. So they're not like slopping down. They've got a tautness to them, and you'd see blades returning and blades coming back on the bottom. If the basin was drained, you wouldn't see this if the basin was full of water. So it's good to occasionally drain your basin and take a look. You'll also hear me interchangeably call these clarifiers and sedimentation basin. So our official term for this in our plant is our secondary sedimentation basin. And the reason we use that term versus a clarifier is in wastewater, when you're talking about secondary clarification, most people automatically go to activated sludge. That's bing, right where their heads go. and with good reason, because there's a lot of emphasis on it. Well, this is not used for activated sludge. This basin in our plant is used for the zoogliomass sloughings from our trickling filter. Okay, so we just want to we use it as a sedimentation basin to be clear when there's people coming in the plant that they're not expecting, to go and be looking for a certain sludge blanket and what's your return rate and all that stuff. It's like, no, it's a sedimentation basin. And then what you'll notice, I don't know if it's really going to come up that great on the camera, but this floor is sloped. Probably actually a little bit more dramatically than my drawing makes it look. And at the very end, you got a blade right here, and it pushes that last little hump of sludge down, and it falls into this hopper. Okay, and this hopper has a suction end on it. It goes to a pump, and I drew a centrifugal pump here. You should know that it's a progressive cavity pump is what typically you're going to find moves sludge. And I've got a couple in the plant. I routinely take apart my progressive cavity pump, not the whole thing, but I open up the box and where the actual mechanism that pushes the sludge is, and I derag it. I don't know, once a month, because we don't have really any preliminary treatment to catch rags here, so our pumps catch them. So anyway, it's just a routine maintenance item that I have to do, and I'll shoot a video when I do it. I think it'd be great. So anyway, and you get to see what a progressive cavity pump looks like. But know that for your test. Centrifugal pumps don't pump sludge. If they do, it's really, really watery. Centrifugal pumps are good for pushing watery stuff. Thicker stuff needs to go through a progressive cavity pump. And just for clarification, a progressive cavity pump is a kind of positive displacement pump. I've had other positive displacement pumps that pump sludge that aren't progressive cavity, but now I'm getting into the weeds about pumps, and we can cover all that in a pump video at some point. So that's a long and short of what you saw up there. You should know all this. You should know about sludge collection systems in plants. It's really, really useful for your exam. And that's about all I got for you on this one today. So if you have any questions, if there's any other material you want to know, let me know. I'll do a video on it, or if not, I'll just keep going with my curriculum. So anyway, hope that helped, and we'll catch you guys in the next one. Have a good day.